Okay, let's go over a second average atomic mass problem, but one where we're going to solve for information about an isotope. This question on the review for honors, number 25, I really like this question because you have to think through and come up with an very important piece of information. So it says, 2 isotopes of rubidium occur naturally, with rubidium 87 at 72.17% abundance and the atomic mass of 84. Now, I think if I remember right, this was mismarked. So if you want to change this in your review, you can. I think the mass number for this one's actually 84. So we're going to be working with rubidium 84 instead of 87. So we know that the percent, we know that the percent abundance for rubidium 84 is 72.17%, okay? And so if I'm going to put that in its decimal form, I'm going to divide by 100 or move my decimal to the left 2 times, so that'd be 0.7217. Okay, and it has an atomic mass, so this mass of rubidium 84 is 84 point, sorry, I think it's actually rubidium 85. Rubidium 85 is actually 84.91 AMU. Okay. The average atomic mass of rubidium. The average atomic mass of rubidium is 85.47 AMU. What is the percent abundance and mass of the second isotope? So we want to know what the percentage is of this other isotope, and we want to know what the mass is of this other isotope. Okay? So the first thing we should note is that since there's only 2 isotopes, these percentages, like the first one was 72.17%, well, if I add that to the percentage of my unknown isotope, that should equal 100%. So if I take 100 and I subtract 72.17, that must mean the percentage of my unknown is 27.83%. And if I want to put that in the decimal form, I'll move the decimal to the left 2 times. And so my decimal form of this percentage would be 0.2783. Great. Now, the equation for average atomic mass for this particular set of isotopes, I have 2 of them, so I'll have 2 sets of parentheses. So I have my first isotope, the mass of 85. I'll multiply that by the decimal percentage of 85. And again, just a reminder, when it said mass number 84 in your guided notes, 87 in your guided notes, it was mismarked, and it should have said 85. So we have mass of 85 multiplied by the decimal form of the percentage of 85 plus the mass of the unknown multiplied by the decimal percentage of the unknown. Okay? I know what this is, I know what this is, I know what this is, I know what this is. It's all included in my list here. What I don't know is this mass of X of my unknown isotope. So I'm going to rearrange this equation to solve for this. Okay, I'm going to isolate this. And the first thing I notice is this whole component here is added to this component. So I'm going to take this and I'm going to subtract it to the other side. So average atomic mass minus this whole thing well, that's going to equal the mass of X multiplied by that decimal percentage of X. And again, what I'm solving for is my mass of this unknown. So I'm going to isolate that by dividing both sides by that percentage. So my final equation will be this mass that I'm looking for will equal the average atomic mass minus the mass of 85 multiplied by the decimal percentage of 85, all divided by the decimal percentage of this unknown isotope. Look at my list, I know everything. And so now I need to just plug it into my calculator. And when I do this, I'm going to plug it in very carefully. So the equation on the top said average atomic mass, so 85.47 multiplied by, oh sorry, not multiplied, subtracted by the mass of 85 multiplied by the percentage. The mass of 85 multiplied by its percentage. Now look, I told my calculator I want to multiply this first and I want to subtract it from that. But this whole thing is on the top of my fraction. And I'm going to divide that by the decimal form of the percentage of X, or 0.2783. So this is going to equal, let's see, 4 sig figs, 4, 4, 4, so this is going to be 86.92 units. Average atomic mass was in AMU, and I subtracted that from mass, which is in AMU, multiplied by a unitless, so AMU, divided by a unitless. So AMU minus AMU will just be AMU, atomic mass units. And then that's my final answer. There's the percentage and the mass of that second isotope.